What's up, everyone? My name is David, and I do competitive programming and leak code questions here on YouTube. Today's question we're going to go over is two-sum. Two-sum is currently being asked by companies such as Amazon, Google, Adobe, Apple, and Microsoft, and is honestly just a great question to get your feet wet and kind of learn about this stuff if you're into data structures and algorithms, or if you're just studying for an interview and you want to see what's going on out there. So the question goes, given an array of integers nums and an integer target, turn indices of two numbers such that they add up to the given target. You may assume that the input will have exactly one solution, and you may not use the same element twice. You can also return the answer in any given order. So they give us a couple of examples here. The first example they give us is 2, 7, 11, 15, the target value of. So in this, the output is going to be 0 because 2 plus 7 equals 9, which 2 is the 0th index and 7 is the 1st index. So next example they show us here is 3, 2, and 4, target of 6, which gives us the 1 index and the 2 index. They also do, show here with we have exactly 2 indexes that are 3, 6. We can use the same numbers, but not the exact same index slash element. So they do give us a follow-up here saying, can we try and optimize this to not have a time complexity of n squared? And they give us that because the on a straightforward approach is to just lock in a given index and then iterate over the remaining indexes, adding each number and seeing whether or not they come out to be the target. But that does have an n squared time complexity. So we got to figure out how to do this. So the optimum time that we could find here probably be somewhere around O to the. We can do this in a single loop by just restating the question. And rather than say what two numbers equal the target, we can say, have we seen the difference between the target and this number before? The reason why this works is because if we take 2 plus 7, 2 plus 7, we can say that that equals 9. But that's the same thing as saying that 9 minus 7 actually equals 2, right? So what we can do here is we can actually iterate each number and subtract it from the target and say, have we seen this number before? And if we have, then those two numbers must add up to equal the target, and therefore we can just return their two indexes. But how do we store that? Well, when in doubt, throw a hash map at it, right? So what this is going to allow us to do is actually take these two numbers, an integer and an integer, being the value that we have, so the value of the index here, so 2, and then store its corresponding index where it's actually located, so in this case 0. And then as we go through the list, we can just keep asking this question: have we seen the difference before? Have we seen the difference before? Have we seen the difference before? And as soon as we find the answer to be yes, we can just in O of one time, so in constant time, we can just grab that index and return it back. So by doing that, we'll just loop through this problem once, and we'll have an O of n time complexity, and let's kind of jump in and see what that looks like. So got this hash map here, this integer to integer. We'll call that diffs. Just be a new hash map and new hash map. And then what we can do here is we can just do a for int I equals 0. I is less than nums.length. I plus plus. And we can ask, so we now have our loop, and now we got to ask our question. Okay, what is the number that we're at, so that way we don't have to constantly keep asking this question. So we got num here, which is nums of I, and then we have the diff that we're looking for, which is equal to target minus num. So now we'll say if diffs dot contains key. Helps here if we write the right value dot dot contains key of diff, so the value that we're looking for. Then what we can do is we can return a new int array that contains the index of the diff. So diffs.get diff, and then we can also return the current one, so just I. Inversely, if it doesn't exist, we will just add ourselves to the list. So we'll just do a put, and we will put num and I. And then because we have to return something, we can just return null. However, it tells us that there's exactly one solution in every problem, so we should never actually fall out here. The worst case scenario is that we just hit this on the very last solution, or on the very last index. So if we run this code, we get that the answer of 0 and 1, which is what we expected to see. Let's go ahead and try this on a second sample, such as 3, 2, 4. So let's go 3, 2, 4 with a value of 6. Let's code again and do. All right, so we see that on 2, 7, 11, 15 with 9, we output 0 and 1, which is what we expected. And then on the second set, we get 2, which is also what we expected. And if we go ahead and submit this problem, see that it ran in 1 millisecond with a time it's faster than 99.67 with memory usage of 39. So the overall time complexity here is going to be, like I said, O to the n, or O of n, I should say, sorry, with a space complexity of O of n as well. And that is 2sum for